Okay, here is another three-phase transformer calculation that really kind of ties a few things together that we've looked at with these kinds of calculations. The problem is 3 single-phase 50 kVA transformers are connected in Y delta to a 208 volt supply. Calculate the current through the secondary of each transformer if supplying a balanced 40 kilowatt load with a 0.8 power factor if the transformer ratio is 2:1. So the first thing you would want to do is draw a little picture of what this connection looks like. So take a minute, stop the video here, and see if you can draw a simple diagram for this connection. Okay, your drawing could look something like this. It's really straightforward. Just tells me that the connection is a Y primary, delta secondary. Our supply is 208 volts, and that's the line voltage on the supply. We're connected to a balanced three-phase load of 40 kilowatts at 0.8 power factor. Now, this question would be pretty easy if we knew the voltage on the secondary, because all we need to do then is take our load and we could convert it to kVA and then solve for current using our three-phase volt amp formula. But the problem is we don't know the voltage on the secondary. So the first thing that we have to do is figure out what our voltage is on the secondary. And something that's a really good thing to remember whenever you're doing questions like this is when we're calculating values for a three-phase transformer connection, we always, as far as voltage is concerned, we always start on the primary with our voltage and work our voltage out from the primary through to the secondary and then out to the load. And then it's the load that determines, once we know the voltage at the load, it's the load that determines all of the currents going back in the circuit. This transformer may have a rating of 150 kVA, but the question I always ask students is, what determines the currents in the circuit? The rating of the transformer or the load that's connected to it? And it's always the load connected to it. So we figure out the currents from the load back in our calculations. Okay, so if our supply is 208 volts, we know the ratio is 2:1. And there's one other important thing we should remember about that ratio is these three-phase transformer ratios always take place where? We say that the ratio for these problems always takes place from the phase on the primary to phase on the secondary. We're using 3 single-phase transformers. If these transformers have a ratio of 2:1, that is the phase ratio from phase on the primary to phase on the secondary. So if the ratio is 2:1, what we need to know is what is the phase voltage on the primary. If the supply is 208 and we're Y connected, the phase voltage in Y is always line voltage divided by root 3. 208 divided by root 3 would give me a V phase of 120 volts. So if our phase voltage on the primary is 120 volts and the ratio is 2:1, that means that the phase voltage on the secondary would be half of that phase voltage on the primary. So V phase secondary is 60 volts. So our phase voltage on the secondary is 60 volts. And if the phase voltage on the secondary is 60 volts for a delta connection, the line voltage that this delta will supply the load is going to also be 60 volts. So V line to the load will be 60 volts also. V phase equals V line for a delta connected secondary. So now we've taken our voltage from our supply and worked it right through so that we know the voltage at the load. Now we can figure out the current that we're looking for. We want to know the current through the secondary of each transformer. So if we're looking for the current through the secondary of each transformer, we are looking for the phase current that this delta secondary would have to supply to the load. And at this point, we can use our three-phase formula with the load that we have to figure that value out. We can convert the 40 kilowatts to kVA. If my three-phase load is 40 kilowatts at a 0.8 power factor, that means the kVA is 40 divided by 0.8, which is 50 kVA. And once I know the total kVA of the load, I can use my three-phase, this is a three-phase load that has a value of 50 kVA. My three-phase total VA formula V line times I line times root 3. And I can rearrange this formula to find the I line. So I line of my load, the I line of my load in the secondary, I line would just be the three-phase VA over V line times root 3, which equals 50 kVA divided by 60 volts times root 3. And we do that on our calculator. We get 481.1 amps. So our line current on the secondary is 481.1 amps. Now it's pretty straightforward to go, if what we're looking for is the phase current on the secondary, on this delta secondary, in order to supply a line current of 481 amps to the load, the secondary current in each phase of my delta connected secondary would have to be root 3 less. Because current in a delta, the phase current is the line current divided by root 3. So I phase secondary equals I line divided by root 3, 481.1 amps divided by root 3, which is 277.8 amps. So that is the phase current that we're looking for with this question. And I hope that this kind of a question helps you to understand how voltage and current work in these three-phase transformer connections. We work the voltage out to the load from our supply. We work all our currents back from our load because the load determines all the currents. And using our three-phase formulas, a question like this is not too bad to do. Hopefully this helps you with questions like this.